Let me just see once. Audio perfect checking. Is it started? Bro, what went wrong? Hello. Let me just see once. Cancel. Audio perfect checking. Yeah, it's working. So yeah, let me see. Hey guys, so welcome to the channel, and this is my 18th video of DSA, and we are like I'm starting a little late, and the reason for that is I was in barber shop after having dinner, and it took a lot of time, not because of my hair cutting. He was like there were two barbers, and one was very slow, and then they started fighting with a Persian that came out from outside. I mean, outside only. So a Persian, I think he was his relative only, and they started fighting, and he was and because of that he was uh, performing I don't know, cutting activity very slow, and like I waited for more than 1 hour, I believe, and I asked him at the starting like how long it will take, and he said okay. He 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 did not tell me he hadn't told me the duration, so I thought maybe 20 minutes and all, and it will finish it, but he took 1 hour, and I just waited. I thought okay, let me wait for it, otherwise I have to come tomorrow, and I do not want to waste my time tomorrow as well. So I just waited, and after that just like I came back around 12:40, and then took shower, and now I'm ready for DSA learning. Okay, so first let me start take you forward, and then we'll start. So if anyone is gonna watch it in future, let me tell you, so I'm on a mission to finish the DSA, and not as just to solve the problems, but here my goal is to you can say finish the problems and learn the meaning of them, so that you can handle other kind of problems. And it's not about just solving problems. Also it's like uh, grabbing the problem solving skill, how they are thinking and how they to approach problems and all. And I think once I'll be practicing more and more problems, then only I'll be able to grab the nuances behind the problems, or you can say reasoning behind the problems, why someone solved that problem with that approach. So you will start figuring out the patterns between the problems, and for that I need to practice more and more. And that is only way I, for example, if you will see the problems, you will be able to detect, okay, it's array, whether can we do we need to use sorting or any other algorithm so that we can solve it efficiently. Let me tell you, at starting when I was in college, right of I think in first year, at that time I just uh, I was aware how to solve a problem, so I was very happy. But once I came into second year, third year, then I found like okay, so we do our goal is not just to solve problems, also to optimize them so that they are. And then I got to know, okay, there is data structure and algorithm. Before that I was like, okay, this is a problem, I just need to solve it, man. But okay, so it could be 4 loops, 5 loops, my goal is to solve them. And that is nothing but the, you can say, naive approach, or you can say what we call it is something else. Naive approach, yeah, I believe naive approach only. And brute force approach, yeah, that's the correct word I was uh, trying to say, or maybe I was just trying to recall it. And okay, so here we are on the mission, and we just covered so far DSA array we have completed, and now we are just moving to another C. If you see, there is DSA playlist, and there are so many cards, or you can say topics, and we are going to jump into the Pine research. And it's great, like we have made progress. And yeah, so we will continue this approach until we'll finish everything, and until we'll not feel until I'll be like confident enough to tackle any kind of problems, or any, it could be array, it could be linked list, it could be tree, it could be graph. Actually, to be honest, graph I haven't solved the problems. Maybe one or two I solved in the past. There are some algorithms, right? Discustra. I know two famous algorithms that is being used: depth first search, breadth first search, and uh, I forgot them, man. So yeah, there are a few algorithms that is being used not only in tree, also in the graph, level order, traversal, and these are the different. Okay, traversal is different, search is DFS, BFS, if you know. Okay, so we are going to learn them all the problems. So we will solve problems, and then we'll uh, throughout, like when we are solving the problems, along with that, like whatever the algorithms will come. For example, here we are going to learn binary search, if you know, where we have two uh, algorithms to search an element. First one, if you know, I mean, there are multiple, you can say, you can use hash to find an element, but normally if you have a given sorted array, the best approach, and that is taking order of log n, is basically binary search. And there is another one that is going to take time of order of n. So that is nothing but the first algorithm, that is basically it's algorithm, or you can say the benign approach or brute force approach, where simply you are iterating through all the elements of array and then you are searching. But in case of binary search, basically you are solving the problems, you are splitting into. First you will take complete array and you will find the mid of it. If mid value is matching with the you can say, if mid value is matching with the target element, then that means that is we found our target. If it is not matching, then we have two decisions, whether we should check in the left array, whether we should check in the right array. And that is based because the array is sorted. So if an element that we are looking for is larger than the mid element, then that means it will be in the right side of the array, right side of the mid. And if the element is smaller than the mid, that means it will be in the left side of it. So then we can shrink our search area, and it's like by 2 by 2 by 2, and until you will get it. So there will be one element. If you are until unable to find, that means it is not available. So this way it is taking uh, order of log n time to solve the problem. Okay, so let's jump to the binary search. And I don't think I need to share screen or what. It's automatically search going to do the right. Yeah, it will do automatically. So no problem. There are 3 sections. Okay, 5 sections, and I think first section will be very easy. So we are going to cover as much as possible. So search X in sorted array. So this is the first problem, and I think this one is nothing but the binary search. So let's solve it. Okay, let's solve it together. So it's an easy problem. So given a sorted array of integers num with 0 based index, find the index of specified target. If target is not found in the array, return the its index. No, okay. If target is found in the array, return its index. If the target is not found, return -1. Great. So I think this is the problem where it's going to take order of log n. Not I think it's going to take order of log n, and we do not need to waste unnecessary time in explaining this problem. So I'll just jump directly to solve the problem so that we can cover and we can focus more on the problems that are complex and where we need more attention, and where I need to focus more. I need to focus them on them instead of solving the you can say, instead of solving the basic problems. Yeah. So I think there is a proverb for it. Okay, so let me solve it. We have target, we have nums. So start. So we can say start will be okay equals to 0, and end will be, you can say, target, no, my bad, len of nums -1, because let's take index of all, and then while start less than end. Okay, equals to end, we are going to take also, both are pointing to same element, so mid will be the same. Okay, so here until we have this number, that means, okay, so if let's say mid will be nothing but start plus end by 2. Okay, great. So if you can say if nums of mid equals to you know what if it is matching with the, you can say, the mid index that we found, it is matching with the target. Oh man, what is this target? That means you can say result found and return the index. So return, we can say mid. Else, okay, what is this bro? Elif, if mid, you can say nums of mid is less than, okay, is greater than the target. That means mid will be nothing but mid minus 1, else will be start equals to mid plus 1. Great. And now we know we are solving them, and return finally, if not then minus 1. So here if you see, we are starting with the first element and last element, or you can say we are taking complete range, and then we are shrinking it, and it will take order of log n. Okay, start next. I think I missed one. Oh, here if you see, end will be no. Here will be end equals to mid minus 1. Here will be start. That's why you, if you are making mistake, you will make mistake. Still I'm taking, is it taking t? I was suspecting that it will take again the same time, but great, it's not. Okay, so it's working. So we solved this, and I don't think we need to waste unnecessary time in this one. Lower bound and upper bound, I know these are the problems, but I never remember them, and I do not know. Given a sorted array of nums and integer x, write a program to find the lower bound of x. The lower bound of algorithm finds the first and smallest index of in a sorted array where the value at that index is greater than or equals to the lower bound. X equals to 2. Zero, 1. Given a sorted array of nums and integer x, write a program to find the lower bound of x. Lower bound or upper bound of x? Smallest index in the sorted array where the value at x is greater than or equals to the given key x. Okay, got it. If we have number, if not found, then that means just greater than that number. Otherwise, if that number is present, then we will be that number only. So here we, okay, let me note down it, how we are going to approach it. So we have given a number, we can say 1 2 2 3. So the problem is simple. Okay, what we will do, we'll calculate mid, and if array of mid is equals to you can say number, if it is greater than or equals to number, that means num, so it will be the, we can say result will be this one, mid. And what we are going to, we are looking for a smallest number. So if it is greater than or equals to, then we need to smallest. So we can say mid will be nothing but mid, sorry, my bad. So end will be now mid minus 1. Okay, we need to check in the left part of it, then only we'll get smaller number, because if number is matching this criteria, that means we have something larger, but now we need to look into the smaller part of it. Okay, I mean left side. Suppose this number is matching, this is mid, that means we need to check this side, then only we'll get the lower index that is equal or greater than this. And we know if this is matching, that means it will be equal if we are getting it. And so we need to look into the, and this one will be result. So as of now, if so this is greater than equals to condition, else that means we have a smaller number. So okay, and at starting we'll keep result -1. So if not, then simply what needs to be done, start will be changed, just we are going to change start equals to mid +1. Great. So yeah, so that's all about it. Okay, now let me solve it. So start equals to 0, end equals to you can say len of nums, and then subtract -1 so that you will get the exact index, because otherwise it's like overflow index, overflow or what. And let me start while start okay less than equals to mid, no, end. So if mid equals to start plus end by 2, and if mid less nums of mid, that means if greater than equals to you can say x, that means it could be a potential result. And if result is this one, that means result equals to -1 default value if not found. Otherwise result will be you can say mid. Okay, great. And finally else, if this condition is not, then okay, we need to change it one more condition, end will be mid minus. Okay, now we need to look in for a smaller number, so this one will be the condition. And else you can say start equals to mid +1. okay, great. And finally a return result. These problems are very simple and easy to approach, and that's why I know how to solve them, because I have practiced so many times, so it's easy to. Okay, what's wrong with it? Okay, 0 and 1 2 3 3 0 plus 3 by 2 means 0 1 2 and 3. So 0 plus 3 by 2 means 1, it will be 1. So this is mid. We'll compare 5 to 968, 5 to 968. So this is greater number, so we'll jump into this section. This one and this one. So we can say right now we have 0 1 2 3. So first will be 0 plus 3 by 2, that will be nothing but 1, and 1 by 1 means this number. So we'll compare, and it is not matching, so definitely it's you can say smaller than. So if number is smaller than, that means start will be mid +1. So this one will be start 2 plus 3 by 2. 5 by 2 means 2, 2.5. 2.5 will be 2. So 2, that means this number. We'll check, bro, are you equal to me or smaller than? So it will say 5 7. Okay, this one is smaller than the number. Oh my bad. So it is saying like you do not need to return -1, but instead of if not found, then return this. So can I say if result equals to -1? Okay. Is there? I know how to use this expression. So if this, then this, if equals to, else you can say result. I think it will work, right? Yeah, perfectly. So let me say it. Submit. Great. So I just misunderstood the problems. I haven't thought about this. And what is the time complexity? Obviously order of log n. And so we have solved two problems. Now let's jump to the third problem. So it's like just brushing up. So upper bound means nothing but, so we have given a sorted array of nums and integer x. Write a program to find the upper bound of x. Upper bound of x is defined as the smallest index I such that nums of I is greater than x. Okay. Size of the array. So for example, we have 1 2 2 3. So if we are looking for 2, then it will be 3, and 3 will be option output with also 3. If we have 3 5 8 15 19, 3 5 8 15 19, and x is 9. So we are looking for 9. So first we'll say 8. 8 is smaller. 15, so 15 will be, and if you see 0 1 2 3, so 3 will be. And let's see how are we going to solve, how we are going to solve it. So my bad, first let me do one thing, move it to the another place so we can solve them. And now, so let me just close this unnecessary stuff. 0 1 2 3. So 0 plus 3 by 2, that's nothing but 1. 0 plus 3 by 2 is nothing but 1, and 1 means this one. So this number, and if you see, this number is x equals to 2, and here x was 9. So if x is 2, we'll say okay, this number is matching. That means it can't be our number. If it is greater than equals to, you can say if the number is less than or equals to x, that means we need, you can say start will be mid plus 1, and if that is not the case, that means it is greater than. Else you can say mid, end will be okay, end will be mid minus 1 and result will be, you can say, this number, and you can say this number is nothing but mid. Finally, if we are not getting any number, then that means we are going to return it. So it's like just tweaking, but I'm not gonna remember it. It's very difficult to remember which is upper bound until someone will tell me. And why it's like looking like some weird. And if you know, today I got cut haircut as well as beard cut. So yeah, great. That's just jokes apart. And yeah, so we can say start will be nothing but, and why the pointer or cursor is moving from flickering, not flickering. 0 end will be len of nums great minus 1. Okay, and now while start less than equals to end, mid will be nothing but you can say start plus what the heck end by 2. Okay, if mid nums of mid is less than or equals to, you can say nums of equals to x, that means the number is either smaller or equals to. If it's equals to, let me do one thing, you can say result equals to minus 1. That means if it is the case, that means we need to move towards rightward, move towards right, or you can say move rightwards direction. And if that is the case, what will be the value? Start will, we have to shift start to mid plus 1, and if not, that means we got something and we can make it. So that means you can say result equals to the particular number mid, mid, and you can say end equals to mid minus 1. So this is the case, and finally return if you can say len of nums if result equals to minus 1, else return what result end, and you can say else we need to return result. Great, so we are able to solve it, I believe. So finally, great, so we solved it again. It's great. So these problems, I know these are very simple, and you know that there is a binary search, you are using binary search, so it's easy to search and find them. And if you have sorted something, then always think about the binary search if we need to find out something, especially in the sorted array, because we can find the some we can avoid the linear search and we can use binary search, and we can, you can say, reduce the time complexity by log n instead of order of n. So order of n to log n, very huge difference will be there. And now I don't know how much difference. Given a sorted array of nums consisting of distinct integers and a target value, okay, search insert position. Given a sorted array of nums consisting of distinct integers and a target value, return the index if the target is found. If not, return the index where it would be if it were inserted in the order. Wow, great. Okay, so suppose we have 135. I'm just thinking, I mean, if number found, if not found, we need to move towards leftward direction. And when we are moving to okay, if number found, so first thing is okay, if number is found, if not found, there will be two scenarios. You can say if the number is smaller than number, that means we need to move leftward direction. if number is just greater than the number, move to rightwards direction. And when we are shifting this, okay, so when we are moving towards left or right, then at the time we are seeing the index, and the index that where we are stopping algorithm, that will be the index of it. I think, yeah, either it could be last index or it could be at the end index. If the number is greater than all the numbers, then it will move to, it will stop at that location. And if number is below that number, yeah, so I think we do not need to check. You can say either will find or not. If not, then we'll get the index of it. Start equals to 0, end equals to okay, len of nums okay, my bad, nums -1 while start less than, what is this, bro? While start less than equals to end. Okay, if not mid equals to start plus end by 2 by 2, it's not by 2, it's like you are chopping the remainder and just considering only the fractional or coefficient, how many times you can multiply with it, and you will get the result, plus excluding the remainder. Very bad explanation I have given to you. Okay, so we have mid, start plus end by 2 okay. Now we have number and we need to check it. If mid, you can say nums of mid equals to result. Oh, okay, so mid equals to nums not target, that means return mid. Yeah, we can return it. Else if nums of mid, you can say is greater than or less than target, that means it should move, end should be mid -1, else start equals to mid +1. And finally, when we got the number start equals to end, if we haven't found that number, we'll check that number start equals to end. If the number is not matching, that means we need to move towards any direction and wherever we are going. So if the number is not matching, then we'll see if this is smaller. 1 minute. Okay, there could be two scenarios. Finally, so maybe let's say we found a location where start equals to end, and at this scenario there will be two cases, that will be in the mid basically and mid of both. So we'll compare, bro, are you equal? If it is mid value is lesser than, or let's say nums of mid is less than target, okay, or it could be nums of mid is greater than target. If this is the case and this is the case, these are two cases. Sorry, my bad, I'm not saying is less than target means we need to move less than target. So start will be, you can say mid +1. If it is greater than, And this one will be the case. Now I'm just curious which one will I value to consider. If mid minus 1, this is the right place of it. If you can say here, what will be the condition? Uh, Greater than int. Then consider restart, and here will be end will be little. 1356. So पहले okay, sorry, but 0 1 2 3. So 0 plus 3 by 2, that is 1. 1 will check 1, so 1 is greater than. Then that means start will be here and end will be here. Sorry, my bad. This one, so we know this one is greater than number. Okay. If number is larger than the it could be the place. But what if number is smaller than this number? So we cannot place there, so it can't be. Just you will see 3 is greater than the 2, so it could be one option. So result equals to 1, then we'll say 0 and we shifted to 1, 0 plus 0 by 2, and that is nothing but you can say 1. So 1 is smaller than this, means the story is over, finished. Okay, and if suppose another case 1 3 5 6 0 1 2 3 5. Okay, what if we are looking for 7? Next 4 will be this value of 7, because 6 is smaller than this. So what we are going to do, first 0 plus 3, we'll say 0 plus 3 by 2, 1 we'll say it's smaller, so we won't say like we have a result so far. Then we'll jump to this number. Okay, we do not have number, then that means we'll jump to this number and this number. So 2 plus 3 by 2 means 5 by 2, 2.52. So we'll say 5. Are you equal? No, it's smaller, so we can't say it as a value. Then we'll say 6. Okay, so we now have 6 only. 6 we say 3 plus 3 by 2 means 3. And 3, can we say, bro, can you be the value? It will say, okay, no. So 3, no, okay, I mean 7 won't be possible. No, okay, I mean 6 won't be possible. 6 is smaller. Then we'll do start will be equals to start mid plus 1. Okay, so it will say, okay, this is now greater than this, so we can say start got at the end. One, two, three, 8, and now we are looking for -1. So what will be the case? Zero, 1, 2, 3. 0, 1, 2, 3. So 3 and 1, 3 by 2, 1, 2 will say 2 is greater than this. So it could be one result. So result can be 1, because here if we'll play. Okay, now we move to you can say start -1 and 1 plus 0 plus 1 minus 1, so 0 by 2. We'll say 0 by 2 means 0. If still it's greater than this number, so we can say end will be so result will be this one. Okay, now we have result. So can we say, like, if we have something, some value in the result, that means that one number can be shifted and all the that number can be placed. Hmm. Okay, but what if that number is not, if it is not present, then whatever the value that we are getting, so you can say this value will be where we, uh, the result that we found. If it is not the case, that means we do not have the number, and so that means we are not able to place it, and we can say it will be nothing but start, whatever the value that we are getting, and start will be always greater than end. Okay, if nums of, then return mid. If you can say result equals to -1, and if nums of mid is, nums of mid is, okay, 1 minute, I'll do it in a proper way, greater than target. Okay, target is greater than 10, that means we need to change it. You can say start, not start, nums of mid is greater than the target value. It means the value is already, and result will be, you can say mid. We know mid value can be put a result because nums of mid is greater than the target value, so we can shift it and we can place it at that location. So this is possible condition. And start equals to mid plus 1. Here what needs to be done, that means if nums of mid is smaller than the target, so it can't be the value, and we can say start will be mid plus 1, and finally return if return if result equals to -1. That means we need to return, we haven't found any start value will be, else simply return what, result. Okay, great. So we made pretty much progress, and today it's great, man. I found a little tricky, but it's not that tricky. So I'll mark it good. Problem solving, good problem. Okay, I'm just thinking. There are two scenarios. Suppose if the number we haven't found, so there will be two results only, I believe. Suppose it is 7. No, it's possible other numbers as well. Okay, so let's jump to the another problem. That is, I think that will complete all the section 5 problems. So maybe tomorrow we'll see another section there. Okay, let's close it for the timing, and for the timing let's jump to the second final problem of the section 1. So floor and seal in a sorted array. Great. Floor and seal. Floor is the upper division, floor is the lower bound, and you can say seal is the upper bound. So given a sorted array and an integer x, find the floor and seal of a number, seal of x in nums. The floor of x is the largest element in the array which is smaller than floor of element, okay, which is smaller than or equals to x. Okay, if number is present, then this is the smallest. Floor of x is the largest element in the array which is smaller than or equals to x. You can say, okay, The ceiling of x is the smallest element in the array greater than or equals to x. Greater than or equals to x. So if it is missing, that means the last element x equals to 5. We are looking for x equals to 5. So 5, if you see, it will be 4 greater than or equals to, so 7. 7 will be the output, and seal of it will that will be the seal, and floor of it will be x of 5. So 5 is not there. That means it's smaller than or equals to 5. Yeah, so 4 will be the value. X equals to 8. So if you see 8 is there, so yeah, if it is available, then that number will be directly x equals to 1. So floor will be this number, and minus 1 comma 2. Just little confusion. Okay, just let me first solve it in the paper. So we have 3, 4, 4, 7, 8, 10. These are the numbers, and now we will start. So you can say 0, 1, 2, 3, 4, 5. These are the numbers. Great. So we'll say, okay, let me switch it. Okay, I'll add one more example. 3. Oh my bad. Both are the same numbers, only x equals to 5, x equals to 8. Let's say for 5. So first 0 plus 5 by 2, that will be 2.5. 2.5 means 2. So 2 will be here 4, and if you see 4 is the number that we are getting. So at a starting we can say seal is -1, floor is -1. We do not know. Okay, so we took this. Now if you see, this number is smaller than 4, smaller than 5. So what it could be? So it could be floor. So we can say floor equals to 4. Correct. And now the next thing, or you can say floor equals to 2, and we know now the number can be okay. Now you know, if the number is smaller than this number, that means it could be floor. Okay, but we need to check if there is greater than this number and that is smaller than this number. Okay, so what needs to be done? You know, this number is smaller, so definitely it could be floor. If nums of mid is less than target, okay, if equals to if value is matching, that means simply return you can say seal, and floor return, because both are weak found. Else if nums of mid is less than x, then floor can be value, floor can be mid, and you can say, and we need to jump into the right side so that we can find the Yeah, we have to find the larger number. So we can say seal. Seal won't, we do not know seal, and here we can say start to mid plus 1, else floor equals to mid and start. Okay, so that means we got the number that is greater than the number. Okay, greater than number, that means seal can be this value, seal can be mid. Okay, and you can say end equals to I don't know. I'm just memorizing an incident that it's been more than, you can say, in an office. In an office, not in my office. I don't know why it's happening, but every time. So maybe I don't know whether should I tell this story or not. But yeah, there is condition that I never wanted to see, and it is frequently happening. And I don't know, it's coincidence or what, but something's wrong. Okay, so leave it. So seal means mid minus mid. We can say it could be potential value for seal, and end will be mid minus 1. So great. Now next time if you see here, so we can say we got this. Now we are going to check this 7. Okay, so we move to, you can say when we found the smaller number, then we move to that direction and we got the bigger number. So these are the two conditions only I see. Again, now if you see, first we found this, so we can say 0 start will be this one. So 3 plus 5 by 2. So 3 plus 5 by 2, that means 5, 8 by 2, 4. 4 will be this condition. 8, we know 8 could be, 8 is greater than the 5, so seal can be 8. And okay, now we know this number is bigger, so we need to shrink it. So we can say end will be mid minus 1, so end will be this. Yeah, so end will be 4. Man, what we did? End will be 3 and start is 3. 3 plus 3 by 2, 3. And finally we got the number that is, so you can say this number could be seal, and after that we know both are overlapping, so that means the numbers we have scanned and we found the numbers. So what is the new here? I do not know. Did I get it properly? I mean, start is equals to 0, end equals to mid minus 1, len of nums minus 1, and floor equals to minus 1, seal equals to minus 1, and while floor less than no man, while start less, I just want to finish start less than equals to end, so you can say mid is nothing but start, bro, really, plus end by 2. Okay, great. So we found the number mid. Now what I'm looking for, okay, we found the mid index, you can say, not number mid. So what if mid equals to not bro, nums of mid equals to x, that means the number is matching, and you can return floor, bro. You can say floor equals to mid, nums of mid, I do not know, seal, and floor will be equal, and I'm just wanted to use and break. We can use it break. Yeah, let me use some different technique. Okay, great. Else elif nums of mid is lesser than nums of mid, you can say is greater than the greater than x. What is the meaning of it? It means we have seal could be nums of mid, and we need to change. Bro, always why cursor is moving here and there. So start equals to my bad bro, and equals to mid minus 1. Else you can say start equals to floor equals to nums of mid. Great. And you can say start equals to mid plus 1. I just feel like my stomach is gut health is still not working fine, or what? I feel little not difficulty. I think it's not perfect. I need to work harder. Okay, so return. Maybe just we'll see. I need to fix it by naturally. I hope you get it. So tomorrow I'll eat lettuce. I don't know. So floor and seal. Great. Oh wow. I got it. You know what? One mistake, and Python is not gonna complain you. Okay, great. So finally, we solved it, and now we have completed one section. I think it's pretty much good progress as of now, and I do not want to put much burden on a single day, and I'll be okay. So maybe tomorrow we'll cover more, because tomorrow is weekend, and weekend is like marathon, and we need to cover all the problems. I feel like maybe I'll stream twice. I don't know. I need to. I mean, I just want to finish things quickly as possible, and I have a lot to. Okay, maybe now I'll practice English. Okay, so that's pretty much for the day, and we have another thing. This is DSA playlist, and I'm just planning to learn the system design as well, because that is also very important. At least we should be aware of what are the how basic things are working. I feel like I'm not that good. I know horizontal scaling, vertical scaling. Horizontal scaling means basically parallelly you are running machines, or yeah. So for example, there is a machine, and now you want more computation, so you added one more machine. So that is horizontal scaling basically. And vertical scaling means just you have a system and you are upgrading it, so vertically you are scaling. And there is a limitation of vertical scaling. For example, if you are upgrading a system or upgrading a laptop, maybe a computer, there is a hardware limit. For example, you can, if you have motherboard of some sort of motherboard version, and there is a limit like how much RAM you can upgrade, how much power of CPU you can use, and all. So there is a coordination between them. So it's like, for example, let's take example of a human. You can you can train a human so that it can work more efficiently, but there is a limitation. You can make the human healthy and he can perform better and better. But what if you are adding one more resource? Like, for example, if you allocated a resource, there is a limitation of that particular person, irrespective of how smart he or she is. But there is a hard limit. You mean, suppose you started someone, maybe you have a bodyguard and you just, it's a smart enough and you top notch bodyguard, but there is limitation, right? But what if you are, instead of one bodyguard, you hired one more bodyguard, so there are two, and similarly three, four, five, and you can get more power, or you can get more control, not control power. So that's how these things works. This is where horizontal scaling and vertical scaling. Horizontal means you are adding more resources, more power you are giving by hiring more resources. And vertical means you are just you are adding more limit, or maybe you can say like person was working for 10 hours now, not that will be the incorrect use. Maybe you just ask them to go gym and exercise so that your strength will be higher and all. What is capacity limitation elimination estimation? Capacity estimation means how much RAM it is expected, how much network bandwidth, how much memory it's going to consume, and also Gaurav's course. They are, I think, partnered. One year access, lifetime access. Why are they? If you notice, things which are here, they haven't mentioned how many video relations and all. Wow. Man, everyone is doing great. Okay, thank you so much and good night. Wishing you all the best, guys. And time to go to bed. I do not know. If you know, I was listening music. Sorry. Zihuzuri nahi. Sorry. Okay, so that's all for the day, and we are going to cover more problems tomorrow. Wow. Okay. Till then, keep grinding, keep practicing, and we are gonna level up.